Well, this is the same double integral, and we're supposed to set it up now as an x first integral instead of y first. As y first, we thought, okay, we're going from this function of x down here up to this function of x up here, and it worked out. And no matter where we were, it was always the same function of x down below, y equals 1 over x, to the same function of x up above, y equals the square root of x. Now, to set it up as x first, we're going to need to change these functions and think of these as functions of y. So this would be x equals y squared. We're just solving for x in these. And this will be x equals 1 over y. So we invert the functions. We now have these as functions of y. And now we're thinking of going from a function of y on the left to a function of y on the right, like this. Now the problem here, we don't go from the same function of y on the left to the same function of y on the right everywhere. That's why this worked so nicely as a y first integral, right? But it doesn't work as nicely now. We actually have to change things. We actually have to break up this region, cut it in half, and do two double integrals if we want to do this x first. And that's a problem. I can label a few other things that we need here. This is the point 3 comma the square root of 3. This is the point 3 comma 1/3 right here. We get that just by plugging into the functions that define those things. This is the point 1 comma 1. And now we can see how we would proceed to do this if we had to do this x first instead of y first. Our double integral would be in this upper region up here. We're going to have a x on the left, 1 over y, to x equals 3 on the right. And the integrand was x squared y dx dy. And we have y from 1/3 up to 1. Sorry, I'm mistaken. That was this region here. Right, so we're going from y equals 1/3 up to y equals 1. And we're going from this function on the left being 1 over y to this function on the right just being that value of y, that value of x, 3. And so that's our first half of this problem. The second half, we'll get the upper portion. And the reason this is different is that the function on the left is a different function up here. Down here, the function is 1 over y. Up above, the function is y squared. So we will be going on the left from y squared up to 3. X equals, I like putting the x's in there. So x equals y squared to x equals 3 on the right. Same function that we're integrating, x squared y dx dy. And now y is going from 1, right? Y is going from this location, 1, up to this location, which is the square root of 3. So that's it. That's the whole double integral written out if we wanted to do x first instead of y first. And hopefully this convinces you that we don't want to do that, right? It does make sense a lot of times to do it one way or the other. And in this case, it definitely makes sense to do it y first because it's just one function of x down below up to one function of x up above. If we try to go x first, then it's different functions of y on the left depending on where we are in the geometry of this thing. So it takes two double integrals to do it this way. We don't want to do it this way, and I hope this illustrated why.